So the world of AI agents is just moving at an incredible pace, right? But there's this one huge bottleneck that keeps coming up. How do we get them to actually talk to our data? Well, today we're going to dig into a potential game changer that could fix all that. It's called the Model Context Protocol, or MCP for short. Okay, so think about it. If you're building with AI agents, you've probably hit this wall. You've got this super powerful agent, but how does it really connect to all your stuff? Your databases, your APIs, your local files, without it just becoming this massive engineering nightmare. This is like one of the biggest headaches developers are dealing with right now. And that's exactly where the Model Context Protocol comes in. Honestly, the best way to think about it is like a new open-source universal translator, but for your AI agents and your data. It's basically the missing link, right? It's designed to bring some order, a common language, to that messy, kind of chaotic connection layer. All right, so to really get how MCP works its magic, we gotta break it down. There are 3 core components to its architecture. And once you see how these 3 pieces fit together, I promise, the whole system just clicks. First up, you've got the MCP host. Just think of this as your main app, the thing your user is actually clicking on and interacting with. It could be a chat app, maybe a code assistant running right inside your IDE, or really any other agent-powered tool you can dream up. Okay, now, sitting inside that host is the MCP client. Its main job? To get the conversation started. So when your app needs to do something that requires outside data, like, say, querying a database, it's the client that kicks the whole process off by asking for the right tools for that specific job. And what's cool is you can even have multiple clients within just one host. And that brings us to the third and final piece of the puzzle, the MCP server. And this is the real workhorse of the operation. The server is basically the bridge that connects directly to all your data sources. It gets the request from the client, does the actual heavy lifting like running a query or hitting an API, and then it sends the results right back. And this is where it gets really powerful. The flexibility here is insane. A single MCP server isn't just stuck talking to one kind of data. No way. It can connect to pretty much anything you throw at it. Relational databases like Postgres, NoSQL databases, basically any API you can think of. Local files, even raw code. This versatility is what makes the whole protocol a game changer. All right, so the theory is great, right? But let's see how this all actually plays out in the real world. We're going to use a super simple chat app as an example to walk through the entire process, from the moment a user asks a question to the final answer popping up on their screen. So let's say a user types into your chat app, "How many customers do I have?" What happens next? Well, first, the MCP host pings the MCP server and asks, "Hey, what tools have you got for me?" The server might come back and say, "I've got a database query tool." Perfect. So the host then bundles up the user's question and that list of available tools and sends the whole package off to the large language model. The LLM, being the brains of the operation, looks at it and goes, "Aha, the database tool is the one for this job," and it tells the host. Now the host knows exactly what to do. It calls the MCP server again and says, "Okay, execute that database query tool with this instruction." The server gets to work, runs the query, finds the customer count, and sends that number all the way back up the chain to the user. See? It's just a really clean, logical, and standardized flow. Okay, so we've seen the pieces and we've seen the workflow, but so what? Why is it such a big deal? Let's zoom out for a second and look at the big picture here and why this protocol really, really matters for the future of AI development. This quote from the source material really just nails it. The key, the absolute heart of the matter, is creating a single, unified standard. I mean, think about it. Instead of every single developer out there reinventing the wheel, creating their own custom, probably brittle way to connect agents to data, MCP provides a common language. And that opens the door for real interoperability and a whole new ecosystem of tools that can all speak MCP. So let's just quickly recap the key takeaways. First, MCP brings a much-needed open-source standard to what is a super complex universal problem. Second, its entire reason for being is to make connecting any agent to any data source way, way simpler. And finally, this is a big deal whether you're building the agents yourself or if your clients and customers are. It's really a foundational piece of the entire AI ecosystem. Which, leaves us with one final big question to chew on. As these AI agents become more and more woven into every piece of software we build, could the Model Context Protocol become the new foundational standard for AI architecture? I mean, could it be as essential as something like HTTP is for the web? Look, only time will tell for sure, but it is absolutely one to keep a very close eye on.